inversely proportional to the pressure at what? At a constant temperature. So that is why we use what? Boyle's law. And this is Boyle's law. So what's P1? P1 is 1. What is V1? V1 is 300. What is P2? P2 is 1.5. What is V2? That is what we are looking for. So automatically, what it simply means is that we make our V2 the subject of the formula. 1 times 300, 300. So V2 will now be 300 over 1.5. I want to solve this. We can multiply this by 10. We also multiply this by 10. Multiply the numerator by 10. Multiply this numerator by 10 to remove the decimal. We have not done anything to that. So that will become 3,000 over 15. 15 year 1, 15 year 2. That is what? 200. So our V2 today equals to what? 200 centimeter cube. So our answer will definitely be what? 200 centimeter cube. So let's see our option. Option A, 750. Option B, 450. Option C, 200. Then option D, 120. And everything in what? Centimeter cube, which is the unit of what? Volume. So there is no other option rather than what? Option C, which is 200 cm cube, which is our answer in this regard. Then question 6. A gas X diffuses twice as fast as gas Y. That's this one. When you see the rate of diffusion, automatically it is talking about no other law rather than what? Grant's law of what? Diffusion. So a gas X diffuses twice as fast as gas Y. So they have given us what? The rate of diffusion. So we are talking about gas X and gas what? Y. So the rate of diffusion of X will be Rx, while the rate of diffusion of Y will be Ry. So they're not telling you that a gas X diffuses twice as fast as gas Y. So automatically what it means is that Rx is equal to 2 Ry. Automatically that means where Rx is 2 Ry, Ry remain the same. That is the rates. Now, if the relative molecular mass of X is 32, the relative, that's Mx, is 32. Find or calculate the relative molecular mass of Y, of gas Y. So My. We have to look for My. In this situation, let's quickly talk about the implication of the law. Rate of diffusion is equals to what? Is inversely proportional to what? Is inversely proportional to what? Vapor density. And there is a relationship between vapor density and relative what? Molecular mass. So that means automatically the rate of diffusion is inversely proportional to what? Square roots of relative molecular mass, since it's inversely proportional to what? Vapor density, square root of vapor density. So it will be like this. Then, if we're not talking about Rx over Ry will definitely be what? Square root of My over Mx, simply because they are what? Inversely related. That's why when X of this one is up, X of this one will be down. If they are directly related, when X of this is up, M of X will also be up. But because they are inversely related, that's why you see this one down and this one is up. Then, what is Rx according to the question? That's 2 Ry. What is Ry? Ry remains the same. Ry equals to, what is My? That is what we are looking for. And what is Mx? Mx is 32. So what do we need to do here? We just Rx, Ry can cancel Ry. So we have 2 over 1 equals to square root of My over 32. So we need to remove this square root. How can we remove the square root? We square both sides. So by the time we square this, and we also square this, these 2 will cancel this, and this one will become 4. So we have 4 over 1 equals to My over 32. Then we are looking for My, so we cross multiply. So our My will now be 32 times 4. and that will be what? 8, 128. So that will be 128. So our answer, the relative molecular mass, which has no units, is definitely going to be 128. So let's see our option and see the one. Option A, 28. Option B, 32. Option C, 64. Option D, 128. So that will definitely be option D, which is 128. The next question, question 7. What volume of oxygen is required to burn completely 45 cm³ of methane at STP? In this situation, we need to know a bit of what? Organic chemistry. So this one is really testing because we need to know the balancing of equation in this regard. If we don't know the balancing of equation, or we cannot balance this equation, there will be a problem along the line. So we must learn. There is a formula for balancing of hydrocarbon, especially when they are undergoing what? Combustion in the presence of what? Oxygen. So in this situation, we have Cx. The formula is Cx over Hy plus x plus y over 2, y over 4, sorry, into O2. Then it will give us xCO2 plus y over 2 H2O. So that is the formula we need to apply. So in this regard, we are talking about methane. What is the formula of methane? Methane is CH4. In the case of CH4, it means our x is 1, our y is 4. Remember, we are comparing this. So x equals to what? 1. Because there's a 1 here, but it is what? Invisible. You cannot see it, but there's a 1 here. So x is equals to 1, y equals to what? 4. So if you want to write this balancing of equation, we have x. What is x? 1. Plus what is y? Y is 4. 4 over 4 into O2. Then it will give us what is what x. X is still 1. You can put 1 here, or we'll leave it that way. Plus what is y? Y is 4. 4 divided by 2 H2O. So let's write this in a format that will be presentable. 4 can cancel 4. We have CH4 plus, this is 1 over 1, which is 1. 1 plus 1, 2, O2. Then it will give us CO2 plus 2 here 1, 2 here 2. That will be 2H2O. So in this situation, we have a scenario like this. So this is a balanced equation for the combustion of what? Methane. So in this situation now, the question now says, what volume of oxygen is required to burn completely 45 cm³ of methane? So 45 cm³ of methane. But if you look at this very well, this is a gas. This is also a gas. This is a gas. This is a gas. So what is the theory of all gases? That is Gay-Lussac's law. That's the theory of all gases. So in this situation, if you look at this question is relating what? Is relating oxygen and what? Methane. So what is the relationship between oxygen and methane as far as Gay-Lussac's law is concerned? Here we can see that we can deduce that 1 mole of methane, which is CH4, is equivalent or is equal to 2 moles. 2 moles of what? O2. Remember, look at this one is 1 ratio 2 ratio 1 ratio 2. So 1 to 2. So 1 mole of methane is equal to what? 2 moles of O2. Then the question now asks us that what volume of oxygen? So this one is very direct. Required to burn completely 45 cm³ of methane. What is the volume of methane there? 1 to 2 is their mole ratio. So when you have 45 cm³ of methane, if 1 mole is given rise to what? 2 moles, automatically 45 cm³ will be given rise to what? 90, because you need to multiply 2 by that, and that will give us 90 cm³ of what? O2. So our answer will be what? The volume of oxygen that will be required to burn 45 cm³ of methane will definitely be 90. So let's go to our option and see the one that is suitable. But in this regard, we have our answers in cm³. So we have A 45, B 90, C 135, D 180. So automatically that will be option what? Option B, which is 90C.